Ladies and gentlemen, good afternoon. I'm Lin Jing from Beijing University of Post and Telecommunication in Beijing of China. I'm so glad to give you the presentation about my paper, the survey metrics and performance analysis of Internet Time Service. NTP Time Protocol, as a widely used network time synchronization protocol, ensures the accurate time of many cases. In the context of Industry 4, all kinds of equipment or devices should interact effectively in order to collaborate in accomplishing the assigned tasks. Many industry applications require timely message delivery. Real-time capabilities are essential new requirements to IoT protocol apart from interoperability. The time provided by Internet Time Service is considered to be reliable and accurate. Inaccurate time can cause serious hazard for system health or property. According to NIST's counting, the Internet service providers receive and process billions of NTP requests every day. However, the performance of time service provided by Internet time service providers is different, and most researchers focus on the performance of the time servers. Therefore, the evaluation of time service providers' time service performance on user side is necessary and important. In this paper, we present an Internet time service monitoring system. It collects the data of Internet time services provided. We then propose 3 service metrics to evaluate the performance of the time survey provided by time survey providers based on the data obtained by the presented system. The Internet Time Survey monitoring system consists of 3 modules: a time synchronization module, a survey monitoring module, and a data acquisition module, as shown in the picture. We select Global Navigation Satellite System as the reference time source of the time of the system to provide a stable nanosecond resolution time reference via the precision time protocol. The survey monitoring module sends a time request message to the monitored time service via the Internet with a period of 64 seconds, and the data acquisition module stores the data in the text form for the data analysis. The monitoring system is located at our campus in Haidian District in Beijing of China. According to the actual NTP implement situation, the existing Internet service providers are mainly divided into 3 categories, namely NTP pool projects, national metrology institutes, and commercial organizations. Through deleting the time service providers which do not respond to the NTP request, we receive the list of 108 time service providers as follows. Since the NTP pool project is a global scope, we divided it into 6 subcategories by geography, and the data collection is lasting 115 days. To analyze the performance of time service from different time service providers, we propose 3 metrics. The first is availability. Availability is used to evaluate the performance of continuously Internet time service. The metric measures the availability of time service as the equation below. Stability is another key metric to evaluate whether Internet time service is stable. We use the standard deviation of the time of step to represent the stability of the services provided by the time service provider. Abnormal situations, for example, vacant values and discrepancies during the service period, have a negative impact on the quality of service. Therefore, we use the proportion of abnormal values during the monitoring period as the anomaly rate to show the robustness of the service. In order to detect and delete the anomalies, we propose an effective algorithm you can see on the picture. From the values of standard deviation in anomaly rate, we can evaluate the performance with stability of time service provided by each time service provider. Accuracy represents an accurate time service provided by the time service provider. We compare the time provided by the time service with the reference time provided by the monitoring system to evaluate accuracy. The formula is as follows. What's more, in this paper, we use the dataset which are processed by the anomaly detection algorithm to calculate the stability and accuracy. We also apply the mean value to represent the value of accuracy. We analyze the performance of aforementioned categories with proposed three metrics. First is about availability. In this paper, we only consider two conditions for the obtained results, that is, receiving the response and receiving no response. In the experiment, our system totally sent 155,215 service requests to each monitored time survey provider in 115 days. We consider that the number of times out occurs less than 300 times, and the availability value is 100%. There are 16 time service providers with 100% availability. The number of time survey providers with availability over 95% is 56. However, there are 5 time service providers having survey availability less than 50%. The result divided by continent shows that the availability is lower with remote areas. This is due to the higher packet loss rate caused by the longer transmission path. The stability results are shown in the picture. The value of anomaly ratio varies from 2.3% to 17.3%. The standard deviations of all time service providers' distribution are flattened. They vary within the range from 7.7 and 158.7, and most of them are less than 100. There are 6 time service providers with anomaly rate value over 10%. Some categories have both the high anomaly ratio and the large standard deviation. According to these, their time service performances of stability are not very good. The time survey providers in the commercial organization categories have better stability. Their standard deviations value and anomaly ratios are various in a small range. The cumulative distribution function diagram demonstrates the accuracy cumulation distribution of 8 different kinds of categories and a total. The accuracy of all services is less than 140 milliseconds. It can be seen in the scatter plot of each time service provider's accuracy that the accuracy of services provided by the commercial organization varies from 1.8 milliseconds and 14.5 milliseconds, which fulfill the requirement of the time synchronization for industrial automation. In addition, we analyze the correlation among hops, availability, stability, and accuracy. We use the IBM Data Analysis Tool, SPSS, to perform correlation analysis. We apply the command traceroute to collect the hops of outing from our system to the time service providers. There are 15 time service providers with more than 40 hops. The remaining time service providers have hop counts between 14 and 62. In order to avoid the impact of geographical distance, we perform correlation calculations based on intercontinental division. It can be seen from the results in the table. The number of switching nodes that pass through the transmission link has no effect on availability, stability, and accuracy, because if the performance of the switching devices are excellent, the switching time from packet to devices are very short and can be ignored. As shown in the scatter plot of accuracy and standard deviation, the accuracy is positively correlated with the standard deviation of stability. In this paper, we built a system to monitor the performance of time service providers all over the world and recorded the data of Internet time service. We also propose 3 metrics: availability, stability, and accuracy to analyze the time service performance of each monitored time service provider. From experimental results, the 56 monitored time service providers come with availability of 95%. And we also analyze the coefficient among hops, availability, stability, and accuracy. The results show that the accuracy is positively correlated with the standard deviation of stability. And we also find that the number of switching nodes in the transmission link has no effect on the 3 metrics we proposed. That's all my presentation. Thank you for your attention.